This is Group 10 and we are going to present the questions of Chapter 5.
I'm Wang Si Yu and I'll be responsible for presenting question 4C. So here is the question. A manufacturing company has launched a new product. Random samples of 120 male and 100 female customers are invited to rate the product. The numbers of male and female customers who rate very satisfactory are 36 and 28 respectively. So can we conclude that the population proportion of male customers who rate very satisfactory is higher than that of female customers at 2.5% level of significance? So let's look at the solution. Let P1 be the population proportion of male who rate very satisfactory, while P2 be the population proportion of female who rate very satisfactory. So N1 is 120 and N2 is 100, resulting in P1 is 0.3 and P2 is 0.28. P hat will then be 0.2909. Since both N1 and N2 are greater than 30, so we can apply the Z test. Then we'll have H naught be P1 minus P2 and equals to 0, and H1 will be P1 minus P2, which is greater than 0. At 2.5% level of significance, we have alpha as 0.025. So the critical region is Z equals to 1.960. Based on the testing difference of two proportions, we'll have P1 equal to 0.3, P2 equals to 0.28, and P hat equals to 0.2909. By applying the equation here, we'll have Z equals to 0.3252, which is smaller than 1.960. Therefore, we do not reject H naught, which stands for we can't conclude that the population proportion of male customers who rate very satisfactory is higher than that of female customers.
I'm Yonglokshi Matthew, and I'm going to present question 4D from 18 and 19 semester 1. The question is about in assessing the generic competence of male and female students admitted to an institution. A rated test is conducted and the score of random samples of the students are summarized on the graph. According to the graph, the mean standard deviation and sample size of male is 70, 7, and 14 respectively, and the mean standard deviation and sample size of female is 72, 8, and 12 respectively. The question asks to do the mean score of all males and females admitted students have a significant difference in 5% level of significance. Step 1. We should let XM be the score of male and let XF be the score of female. Assume that XM is normally distributed with mu M and sigma square M. XF is normally distributed with mu F and sigma square F. Variance of M equals to variance of F, and the scores are randomly selected from the population. Mean and SD of male equals to 70 and 7. Mean and standard deviation of females equals to 72 and 8, as it mentioned above. H0 will be mu of M equals to mu of F. H1 will be mu of M does not equal to mu of N. And alpha will equals to 0.05 at it have 5% level of significance. Since the size of male sample equals to 14 and the size of female sample equals to 12, which is smaller than 30, the t-test should be used. The degree of freedom is V equals to 14 plus 12 minus 2, which is equal to 24. S squared P2 equals to N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared over N1 plus N2 minus 2. It will equal to 13 times 49 plus 11 times 64 over 24. The answer will be 55.875. According to the T table on the right, T alpha over 2 and V will equals to T 0.025 and 24, which is equals to 2.064. The critical region is T smaller than negative T 0.025 and 24, equals to negative 2.064, and T will larger than T 0.025, 24, which is equal to 2.064. Under H0, since we assume sigma square m equals to sigma square f but unknown, the test statistic will be t equals to mean of x1 minus mean of x2 minus t0 over sb times the square roots of 1 over n1 plus 1 over n2. It will equals to 70 minus 72 minus 0 over square root of 55.875 times square root of 30 over 84, which is equals around negative 0.6801. Since negative 2.064 is smaller than negative 0.6801, smaller than 2.064, we should not reject H0. As a conclusion, the mean score of all males and females admitted students do not have a significant difference in 5% level of significance. Thank you.
I am Learn Oil Lam. I am responsible for representing the question 5A in 2018 to 2019 semester 1. The question is, the midterm test of a subject consists of two sections, Section A and Section B. Scores of 10 randomly selected students attempt the test are listed in the following table. Assume that the population are normally distributed. Test whether the mean score of Section A and Section B of all students who attempt the test are the same at 1% level of significance. First, we let D be the difference in total score, which is computed by the score of Section A students attempt the test and the score of Section B students attempt the test. D is normal distributed with mu and sigma square, and random sample is drawn with replacement or infinite population size. The sample size is 10, the sum of difference is equal to 42, and the sum of the square of difference is equal to 750. Therefore, we calculate the sample mean, which equals to 4.2. The sample standard deviation equals to 7.983315936. The null hypothesis is mu d equals to 0, and the alternative hypothesis is mu d larger than 0. Also, a significance level alpha equals to 0.01. The sample size is 10, which is smaller than 30, and the population standard deviation is unknown. As we can assume that the population has a normal distribution, we use the t-test. The degree of freedom is equal to 9, thus our critical value is equal to 2.821 by using the t-distribution table. Under the null hypothesis, the test statistic is equal to 1.66365359. As our test statistic is smaller than the critical value, we do not reject the null hypothesis. To conclude, the mean score of Section A and Section B of all students who attempt the test are the same at 1% level of significance.
So let's move on to the next question, which is 2018 to 2019, Semester 2, Question 5A, and I'm Chen Qilin. The production manager of a battery factory wished to determine whether the average life expectancies of batteries manufactured by two machines are different. A random sample of 36 batteries produced by machine 1 shows a sample mean of 375 hours and a standard deviation of 110 hours. And a random sample of 36 batteries produced by machine 2 indicates a sample mean of 362 hours and a standard deviation of 125 hours. Using the 1% level of significance, is there any evidence of difference in the average life expectancies of the batteries produced by the two machines? So first, we let X1 be the average life expectancies of batteries manufactured by machine 1. And let X2 be the average life expectancies of batteries manufactured by machine 2. And we have N1 equal to 36, X bar 1 equal to 375, and sigma 1 equal to 110. And N2 equal to 36, X bar 2 equal to 362, and sigma 2 equal to 125. And we have the null hypothesis as mu1 minus mu2 equal to 0. And we have the alternative hypothesis as mu1 minus mu2 not equal to 0. And since both samples are of size greater than or equal to 30, we use C statistic, and this is the formula. And now we got the formula of C equal to 375 minus 362 minus 0 over the square of 110 plus the square of 125 over 36. So we got C equal to 0.4684. Because this is a two-tailed test, at the 1% level of significance, we will find the C alpha over 2, and which is equal to 2.58. The critical values are C equal to negative 2.58 and C equal to 2.58. Because the C value is 0.4684, which is greater than negative 2.58 and less than 2.58. So the test statistic of C equal to 0.4684 does not fall in the critical region. We would not reject the null hypothesis. So there is insufficient evidence to conclude that there is a difference in the average life expectancies of the fat trees produced by the two machines. And now I will pass the time to my groupmates to talk about another questions.
I'm Moyi Man. Today I'm going to present mock examination 1 question 4C. The question said that a health spa has advertised a weight reducing program. A somewhat overweight executive is interested in the program but is skeptical about whether the program can help participants to reduce an average of more than 17 pounds. The spa allows him to select randomly the records of 10 participants and record their weights before and after the program. These data are given in the following table. Assuming normal populations, is there any evidence to suggest that the program can reduce on average weight of more than 17 pounds at 5% level of significance? First, I will let mu1 be the weight of participants before the program, mu2 be the weight of participants after the program, and D be the difference between the weight of participants before and after the program. And below is the difference in weight of every participant. We have the number of participants n equals to 10. The sample mean can be calculated by adding all 10 differences together and divide it by 10 participants, and we can calculate 19.7 pounds. For the sample standard deviation, it is equal to square root of the square of each value of D and add it together, then minus the sum of the values of D and then square the result and divide it by n, and finally divide the whole thing by n minus 1, which can calculate 4.398231,968 pounds. Next, we have the null hypothesis H0 of the difference of mu1 and mu2, which is mu_d equals to 17. And the alternative hypothesis H1 is mu_d larger than 17. Also, we have alpha, which is the level of significance, equals to 0.05. Then, since n equals to 10, which is smaller than 30, t-test should be used. And the degrees of freedom is equals to n minus 1, which is 9. So the t of 0.05 and 9 is 1.833 shown on the table. And the critical region is t larger than 1.833. So we will reject H0 if t is larger than t of 0.05 and 9, which is equals to 1.833. For test statistic, t equals to the sample mean minus the hypothesized difference in means, then divide by sample standard deviation divided by square root of n, which is equals to 1.941268,615. Since t equals to 1.941268,615 and it is larger than 1.833, we will reject H0. And evidence is found to show that the program can reduce on average weight of more than 17 pounds.
I am Emily Knight, and I am presenting the answer for Mod 3 question 4D. So let's read the question together. A merchandising firm has 4 package designs for its new domestic product and is interested in the preference of housewives in the city. Its marketing department presents the 4 designs to a random sample of 400 housewives and asks for their preference. So the question asks us to conclude whether the housewives have equal preference for the 4 designs at 1% level of significance. First, let's write down the null hypothesis, which is the housewives have equal preference for the 4 design, and the alternative hypothesis is the housewives do not have equal preference for the 4 design. Second, by alpha equal to 0.01, the design of freedom V equals to K minus 1, whether there is design A, B, C, and D, so the total number of K is 4, and V equal to 4 minus 1 equal to 3. Firstly, by using the following table, the answer can be found out. First, we should find out the expected value of design A, B, C, and D are 400 divided by 4, which is equal to 100. For the observed value of design A is 400 times 0.21 equals to 84. The observed value of design B is 400 times 0.28 equals to 112. The observed value of design C is 400 times 0.22 equals to 88. And the observed value of design D is 400 times 0.29 equals to 116. For the difference between observed value and expected value squared divided by expected value, the amount of design A, B, C, and D are 2.56, 1.44, 1.44, and 2.56. Thirdly, under the null hypothesis, test the statistic is chi-square, which is equal to the sum of the difference between observed value and expected value squared divided by expected value, as 2.56 plus 1.44 plus 1.44 plus 2.56 equal to 8. The chi-square equal to 8. Fifthly, we should find out the critical value. From alpha equal to 0.01 and V equal to 3. By using the table of chi-square distribution, we can find out the critical value is 11.345. Since chi-square equal to H, which is smaller than critical value of 11.345, we can conclude that the housewives have equal preference for the 4 design and do not reject null hypothesis.